The surface area and volume of a sphere can be found using using formulas S equals 4 pi r squared and V equals 4/3 pi r cubed for surface area and volume. Find the volume and surface area of each object. Okay, so for our basketball, we have a radius of 6 inches. If we're trying to find the surface area, we substitute in 6 for r for the radius, and calculate that in your calculator, and you have the surface area. Okay, for volume, we set up our formula like 4/3 pi times 6 cubed. So we can use, in our calculator, we can use control divide. Okay, 4/3, and right arrow to get out of the fraction. Pi, the pi button is at the very bottom of your calculator down by the letters right here. Pi. Okay, and it gives you some choices. We just want pi, we just want the first one, so we can enter. And then we have times 6 cubed, or 6 raised to the 3rd power. Okay? Does everybody understand? So that is 904.8 or so inches cubed. Okay? Same thing for a baseball. Our diameter this time is 9.2, so we have to be careful because what we need is our radius. And it's 9.2 centimeters, so in case you were confused by that to begin with, don't be. All right? So we have 4 times pi times, what is half of 9.2? If you need to put that in your calculator real quick, you can. 9.2 divided by 2, that is 4.6. Okay, so we may want to make a note over here. Our radius is actually 4.6. Okay, so we have 4 times pi times 4.6 squared. Whoa, yikes, don't do what I did. 4 times pi times 4.6 squared. Okay, see what I accidentally did? I accidentally had already put in 4 pi and didn't pay attention. Okay, so just be careful of that. So we get 265.9 centimeters squared. Finding the volume of a baseball, same kind of deal. We're going to have to use the radius and not the diameter. So we're going to do control divide to get my 4/3. 4/3 pi times, what was it, 4.6? 4.6 raised to the 3rd power. Okay, that's 407.7 centimeters cubed. We're dealing with 3 dimensions here, so it's cubed. Okay, radius of a cantaloupe. Okay, normal size cantaloupe is probably has a radius of 7.5 centimeters or so. So we have 4 pi times 7.5 squared. 706.9 centimeters squared. And if we do our volume of our cantaloupe, control divide for 4/3 pi times, what was it, 7.5 cubed. 1767.2 centimeters cubed. Okay, so that's just some background information. Plus we haven't done volume and surface area in a while, and it doesn't hurt to brush up on things like that. Okay, a function v of s equals 0.094 s to the 3/2 power can be used to find the approximate volume of a sphere in terms of its surface area. Meaning, if we know its surface area, we don't have to know the radius or anything like that. If we know the surface area, we can find the volume from that formula, from this given formula right here. Okay, so use the entries for the 2 spheres above to verify that this function works. Okay, so for a basketball, if we're talking about a basketball, we know the surface area of a basketball, we know the volume of a basketball, if I could point to the right ones. Okay, so this is saying we take V of whatever the surface area of a basketball is here. Okay, so anywhere there is an S, we're going to put in the 452.4. So that's why there's a 452.4, because that's where the S was in the formula to begin with. Okay, so if we do that calculation, we do 0.094 times, where's my parentheses? There they are. 452.4 close raised to the 3/2 power. Okay, so we can go ahead and do the fraction and do 3/2. Hopefully you know that you can do 1.5 there, because 3/2 is 1.5. But we did have a discussion yesterday about using fractions versus decimals, so it's really up to you at this point if you understand what's going on. Okay, so we end up with 904.5. 904.5. Well, what was the actual calculated volume of a basketball? 904.8. So how close was that? Well, it does say the approximate volume. So is that approximately the volume of a basketball that we measured with the actual formula? Yes, it is. Okay. So what about a cantaloupe? Well, what is the surface area of a cantaloupe? 706.9. If we put it here, we also want to put it here because that's where the S was. This is also where the S was, so we need to fill that in as well. So we say 0.094 times 706.9 raised to the 3/2 power. 1766.7. 1766.7. Is that the approximate volume of a cantaloupe that we calculated with the formula? Yes. Okay. So something extra really quick. Where does this function come from? Right? If we take the surface area and we actually solve for r, that means we're going to have to divide both sides by 4 pi. 4 pi. So r squared is s over 4 pi. What about, to solve for r, we take the square root now, correct? So we actually get r equals the square root of s over 4 pi. Okay? Now, what if we substitute this expression for r into the formula for volume? Okay? So we have v equals 4/3 pi times the square root of s over 4 pi cubed. Okay, that's where this expression comes from, because they simplify the pi's, they raise things to the right square roots and things like that. Okay, I just wanted you to see where that came from, right? So suppose a spherical balloon has a surface area of 325 centimeters squared when it's deflated. So let's use this formula to determine how many cubic centimeters of air it would take to fill the balloon without stretching its surface. Okay, so we take 325 and we substitute it in for S, because that's the surface area. So V of 325 equals 0.094 times 325 raised to the 3/2 power. Okay? Put that into our calculator. So 0.094 times 325 raised to the 3/2 power. 505.7. Okay? 550.7. And that would be centimeters cubed because we're dealing with volume. All right? Now, more and more air can be pushed into this balloon until it reaches a volume of 2,000. Do you understand why? Well, because the balloon is stretchy. Okay? So, if more and more air can be pushed in to reach a volume of 2,000, use this formula to figure out how much the balloon's surface area has been stretched. Okay? So, what value of S would solve this formula to make it equal 2,000? Okay, so 2,000 equals 0.094 s raised to the 3/2 power. Okay, so there's a couple different ways we can do this. We can actually open a new document. that is a, no, I don't want to save it, that is a graph. And we can put this equation, 0.094 x raised to the 3/2 power. And go and look at the table. Control T. And scroll and scroll and scroll. Because what am I looking for in the Y column? Yeah, I'm looking for 2,000. Okay. Now if I was smart, I would go to my menu and my table, and I would edit my table settings, because at 129 it's only 137, and I got to get to 2,000. Okay, so I want to start my table at a different place. What about 500? Okay, I'm getting closer. What about menu, table settings? Let's go 600. Closer. Menu, table settings, 700. Oh, that's getting pretty close. I think 800 would probably be too much. So I'll just sit and scroll for a while. See, look, I'm already at 1900, so that's good. And I need 2,000, right? Whoop. So look at that. Okay? So between this, my surface area would be between 767 and 768. But boy, that was annoying. Having to scroll all that, having to figure out how to set my table. I sure wish there was an easier way. Oh, okay, we could set up and solve an equation, like algebraically. Okay? So if we're solving this equation algebraically, we would first isolate the variable. Okay? By dividing both sides by 0.094. Okay? So isolate the, oh, I already told you this, sorry, variable. Isolate the variable and the what? The variable, oh, the variable that has the exponent. And remember, we can also use the word power. Okay? So if we divide both sides by 0.094, we get, excuse me, scratch pad, 2,000 divided by 0.094. Okay? 21,276.6. 21,276.6. Okay? Raise both sides to a. Well, how am I going to get rid of that? What can I multiply that by? Because remember, our rules are, if I multiply something, if I raise something to a power, I multiply those two. So I need my answer down here to just be s. Or another way to think about it is s to the first. So what can I multiply this by to make it become a 1? Well, the only thing I can multiply it by is its reciprocal. So we need to raise both sides to a reciprocal power. Okay? So I have 21,276.6 also raised to the 2/3 power. Because I can't do something to one side and not do it to the other. Okay? So I still have that number saved in my calculator, so I'm going to raise that number to the 2/3 power. And I get 767.8. 767.8. Now, is that something close to what we got a minute ago? Yeah, absolutely. Okay? But this is more of a guess, and this is more of an exact answer. Okay? So use these steps to solve these problems. You also have these answer bank over here to help you understand that there's only 8 questions and there's more balloons than that, so not everything over here is going to be an answer. But in case you want to use that. Okay? I hope you're having a great day. I hope you continue having a great day, and I will see you soon.